EES, which is pronounced EASE, is an acronym for Engineering Equation Solver. EASE provides property information for many different substances. There are more than 700 built-in substances in EASE right now, and there are more being added all the time. These substances correspond to different types of models that range from incompressible to ideal gas to real fluid models. There are more than 2,000 additional substances available in the built-in NASA library, and an additional 260 or so more substances that are available using RefProp if the EASE RefProp interface is installed. So in total, there's almost 3,000 different substances that you can access in the EASE software, and obviously it can be difficult sometimes to identify the substance model that you need for your application. The Substance Information Dialog is available in EASE programs version 11.582 or later, and it's meant to make finding the substance that you need for your problem easy, and also finding information about that substance easy. The Substance Information Dialog is accessed by selecting Substance Info from the Options menu. The dialog consists of 3 boxes. The left box is the Search for Substance box, and that's where you're going to set up your query to try to identify which substance you need. The middle box is then the list of the substances that are found by your query, and it's populated by all the substances that match your search requirements. And then finally, the right box is the Substance Information box, and that's going to provide information about whichever substance you choose to look at. So let's start with the Search for Substance box. This box requires that you select one or more of the substance types, and these correspond to the substance model that's being used. As each selection is made, you can see that the Substances Found box will be populated with a list of available substances associated with each type. So real fluids use a detailed equation of state and are valid from compressed liquid all the way through the vapor dome and into the superheated vapor region. Ideal gases and incompressible models use much simpler equations of state. Brines are incompressible models of mixtures like ethylene glycol and water. Mechanical design are incompressible models of solids that include more detailed properties that are related to material strength and are therefore useful for calculations involving strength of materials and mechanical design considerations. Mixtures here include substances like ammonia water and lithium bromide water. Psychrometrics are properties of air-water vapor mixtures. The NASA library includes both ideal gas and condensed matter substances, and finally, if you have the EASE RefProp interface installed, then you can easily get properties for the built-in pure fluids and mixtures that are available in RefProp. And you can also build other mixtures in RefProp and access them in EASE as well. So you can select more than one type box, and that then lets you populate the Substances Found list with more possible substances. You can filter this Substances Found list down based on other selections that you make in the left-hand box. So you can make selections in the property list and or the category list. So for example, here I'm going to set up a search where I find all the real fluids and all the incompressible substances that have the saturation pressure function, so PSAT, and also are categorized as eutectants. And you can see then here I have this relatively small set of those substances that match my search criteria. If I want to undo a selection in the property or category list, I just hold down the control key and make the selection again, as I've done here. The search for box up here at the top allows you to further filter your results based on a string. So for example, I might want a list of all the substances that are built into EASE that include the word oxygen anywhere in their name or anywhere in the description of the substance. To do that, then I will select all of the built-in substance types, and then I'll type the word oxygen in the search for box and select the search button to carry out that search. And in the Substances Found list, you can see that there are 4 substances that include oxygen. We can get details about each of these substances by selecting them in the Substances Found box, and then that will cause the Substance Information box to be populated with information about that particular substance. So here we can see that the substance copper OFHCAN is a model of oxygen-free copper that has been annealed and is part of the mechanical design library. So you can see down here that the properties that are available for this particular substance include things like ultimate strength and shear. Copper OFHC HD is a model of the same material, but this one has been hand drawn instead of annealed. You can see they've been picked up because the word oxygen appears here in the description. The substance O2 is an ideal gas model of oxygen, while the substance oxygen is the real fluid model of oxygen. Selecting the fluid information button will bring up the appropriate help page to provide more information about whatever substance it is that you're looking at. Finally, selecting any of the properties that are available for that substance in this list will populate the example box here at the bottom with an appropriate formatted call to that property for that particular fluid. In many cases, you can adjust the independent variables that are used to specify the state, and you do that by changing the selection in these drop-down boxes. So for example, here I can change from temperature and pressure to temperature and specific volume. The index box to the right of the example box can be filled in, and whatever you put in here will be applied to all of the properties as shown here. So maybe this is state 1, and I would put a square brackets 1, and that would apply that across the board here. Finally, if you select paste, then you would paste that function call into the equations window, which would prevent you from having to type it. Alright, this is one of a series of tutorials that is meant to describe the operation of the EASE software. If you'd like to get more information about EASE, obtain the software, or access more of these tutorials, please go to the website fchartsoftware.com. These tutorials are excerpted from the book Mastering EASE, which can also be obtained from that website.